Hello everybody and welcome to my first video using this program. So let's see how it goes. Let's get started. This type of integration I've called abstract integration because we're really looking at the concept of what happens when we integrate as opposed to having a function and integrate it. You'll notice for this question you don't actually have a function. You've got the graph of a function, but we don't have the formula or anything like that. So we're being asked to integrate f of x between 0 and 8. Evaluate the integral of 0 to 8 of f of x dx using geometric formulae. So by geometric formulae, it means we're going to be using area of the shapes that we have, and we can see that there's actually three different parts to this question. There is three different areas. So let's call this first part here area 1, and the second part area 2, and many of you geniuses out there might have guessed the name for the third part. We're going to call it area 3. Okay, notice that area 3 does stop at the line x equals 8 because we're told that we're integrating between 0 and 8, so we're stopping here at that upper boundary of 8. Okay, so this question doesn't tell me to find the area of the function. It just says to integrate between 0 and 8. So we aren't going to take the absolute values, we're just going to do the integration. Area 1 is going to give me a positive value because it is above the x-axis. Area 2 is going to give me a negative value, and area 3 a positive. So in order to find the integral between 0 and 8 of this function f of x, all we really need to do is to take area 1, it's positive, and then we're going to subtract area 2 because it's negative under the line, and then we're going to add area 3. So we have to find the areas. Area 1 is a trapezium, which I believe you guys call a trapezoid. The formula for all of these is in the formula book. Hopefully you already know it. So area 1 is taking the average, really, or the mean of these two lengths, A and B, the two parallel sides. So that's going to be half A plus B, and timesing it by the perpendicular height, which is going to be this pi here. So half A plus B times H. Let's substitute the values in. So our A value is from 2 to 3, so that's going to be 1. Our B value is from 0 to 4, so we've got 4. And H is from 0 to 2, so 2 for H. This gives us a result of 1 plus 4, 5, divided by 2 gives me 5 over 2, times by 2 gives me 10 over 2, which gives me 5 units squared. We can then look at area 2. Area 2 is just a triangle, and I really hope you know the area for a triangle. That's going to be half base times height. Why am I using A and B? How embarrassing. All right, half base times height, or base times height divided by 2, same thing. So base and height, we just need to substitute those values in. The base is going to be from 4 to 7, so that gives me 3. And my height is going to be from 0 to negative 4, so my height is also 4. And evaluate that result. That's going to be 3 times 4, 12. Half of 12 gives me 6. And then I've got my third area 3. Also a triangle, so I write out the equation again, the formula again. I'm just going to substitute the values in. So we've got half base, in this case is going to be 1 times height of 4. So this is going to give me a value of 2. And as we said earlier, to find the integral between 0 and 8, we need to add area 1 and area 3 because they're above the line, they're positive, and subtract area 2. So I'm just going to finish that off over here. The integral, in fact, let's add a different colour. I'm just going to put it in here, save me using more space. Area 1 is going to be 5. Area 2 was 6. And area 3 is 2. So overall that gives me a final answer of